Good morning, students. I wanted to go ahead and start with chapter 2, even though your test is on Thursday for chapter 1. We are starting chapter 2. We are going to be dealing with inequalities in this chapter, which is something that you have done before. But of course, we will dig deeper into each topic and learn a few new things in algebra. Okay, so let's go ahead and start with the Explorer. And they give me a diagram of life expectancy in the bottom income quartile. Okay, so they want to ask me some questions and they give me the life expectancy at age 40. Okay, and then the different places. So let's take a look and start after you look at the diagram and you see that some areas in the light yellow and then the orange, the red, and the maroon, which seems to be the one that has the least life expectancy. Okay, now let's move on to answering some questions. So explain what the diagram represents in your own words. So the graph shows the life expectancy for lower income people in the US when they are 40 years old. Which state do you think has the highest life expectancy for lower income people at age 40? Which state do you think has the lowest? Explain your reasoning. Well, in order to really see the demarcation of the states here, you would have had to look at another US map, which actually shows you the states, okay? And they would help you find the states, because we can always find Florida, and of course Hawaii, California, but the other ones are not that simple when they're not really marked on the map. So Vermont is the highest. Why? Because the entire state is light colored, right? In that light yellow, in those light yellows. Okay. Nevada has the lowest. Almost the entire is mostly dark red. Or maroon, almost like wine color, very, very dark. On the next page, let's continue answering some questions. Which city do you think has the higher life expectancy for lower income people at age 40? Detroit or Miami? Miami. And for us, of course, that's easy to find on the map because that we recognize it. So the area is lighter color than area around Detroit. Write several observations you can make from the diagram. Okay, so I can see that states along the coastline, whether it's east or west, tend to have higher life expectancies. Midwestern states tend to have the lower life expectancies. Explain how you can represent one piece of information from the diagram graphically. Well, we could say, well, I want to graph the point 77.9 on a number line with a closed circle pointing to the left to represent lowest life expectancy. And do the same for the rest. Because they're using inequalities to describe the life expectancy. And the map and the colors, so several representations. At the bottom of your page, it says, why is it important to be able to interpret real-life data sets that are represented by maps, diagrams, and other data displays? So in a general definition, the interpretation of data helps researchers to categorize. We can see that with the life expectancies, the different sections, right? Less than this, less than this, less than this. Manipulate. That means work with the data and summarize the information in order to answer critical questions. Once you manipulate your data that it's giving you the different answers, like the life expectancy, okay, at the age of 40 in the different states, cities actually, then you're able to answer questions. Then I guess you would say, okay, so why are the coastal cities, people live longer? What is contributing to that? And then from there, you can do more research and more data gathering. So today we're going to start with writing linear inequalities. About a week or two ago, I gave you a paper that I asked you to keep in your binders that has a lot of the translations from words to symbols of equations and inequalities, okay? And they even had examples, okay? So those are very useful. They do give you some here in this table in the book, okay? So inequalities contains these symbols, okay? And then we have some of the phrases here in this page, okay? And that's wonderful. We do have some, but in the paper that I gave you, you had a more, I guess, longer list of phrases to help you with this. As always, the book gives you some information and some completed examples about writing inequality. So writing means translate from the sentence to the symbol. And number W minus 3.5 is less than or equal to. So notice that now is not an equal sign, okay? Is has a few words after that now denote or mean that it's going to be an inequality, okay? So the book does a beautiful job of highlighting it in a different color. So is less than or equal to is your inequality. That splits that inequality into two parts. Once you know that part, then to the left, you translate, and then to the right, you translate. Okay. And then over here, we have 3 is less than a number n plus 5. So is less than is the symbol, 3 on the left-hand side, and plus 5 on the right-hand side. And the next one, 0 is greater than or equal to, that's your symbol, okay? And then to the left is 0, to the right is twice a number x plus 1. Okay, so it is really a good idea to use a highlighter to highlight what is the inequality, and then immediately that separates the sentence into two parts. So let's take a look at number 1. A number B is fewer than. Okay, so I'm going to highlight in all of them and then I'll work them out. So is fewer than is our inequality symbol. 11 is more than, that's our inequality symbol. -7/10 is at least, that's your inequality symbol. And the sum of a number and z and 16.2 is at most. So we have highlighted the inequality symbol, and now let's translate. So is fewer than is less than. B, a number B, less than 30.4. Number 2 is more than, and then I have 11 is more than a number y divided by 4. -7/10 is at least, okay, is at least is greater than or equal to. So -7/10, and now let's take a look. Twice a number k minus 4. Okay, so twice a number k minus 4. Number 4, the sum of a number z and 16.2 is at most, that is less than or equal to 30. And now the sum of a number z and 16.2. Sum is addition and 16.2. And by highlighting the inequality symbol, you separated and made the translation so much easier. Okay, because then you have two small pieces to translate. On the next page, page 90, a mathematical sentence uses the symbol less than, greater than, less than or equal to, or greater than or equal to is called an inequality. Remember, the definition of the inequality given to us earlier is a mathematical sentence that compares expressions. Okay, we have always more than one answer. Now it says here, which is different? Write both inequalities. Okay, so which is different? Let's first translate them. But I'm going to highlight. This one says is greater than or equal to, is no less than, is no more than, is at least. So let's take a look. This one is W greater than or equal to -7. W greater than or equal to -7. W less than or equal to -7. And W greater than or equal to -7. So which one or which is different? Well, you can see that this one was the only one, the third one, that the inequality symbol was different. Okay. Continuing to solutions solving now inequalities. Okay. So several things I want to highlight in this page as we go through it. The solution of the inequality is a value that makes the inequality true. An inequality can have more than one solution. The set of all solutions is called the solution set. Okay, so the word set can mean a collection of similar things that belong together. Okay, now, so they have a value of X, and then they give you an inequality, and they're asking you whether it's true. So you plug in the -6 on 4X, and you can see that on the first one is true, -1 is greater than or equal to -2. On the next one is true as well. On the next one, -8. Now we end up, why is the second one, by the way, true? Is because you have that equal sign. So it's not greater than, but it's equal. So it's considered true. The next one, though, -3 is not going to be greater or equal to -2. And then they bring up the symbol with the bar crossing it, like the not equal to, okay? So not greater than or equal to, it means that it's not greater than or equal to, and they bring up the symbol at this point. Then they give us a few more examples, like this wonderful book always does. And they say, tell whether -4 is a solution of each inequality. So they give you the value of X, and all you have to do is plug it in and work it out. Okay, all you have to do is plug it in and work it out. So -4 is not a solution of the first inequality, but it is a solution of the second inequality. Okay, so now let's go to the next page, page 91. And let's go ahead and work these examples, 7 through 14. And it says, is 5 in the solution set of x plus 3 greater than 8? Well, so if x is equal to 5, then x plus 3 greater than 8, 5 plus 3, 8 greater than 8. And no, because 8 is not greater than 8. We do not have an equal sign there. Okay, so nope, it's not. In 8 through 13, we are going to tell whether -6 is a solution of the inequality. Let's work them out. Okay, so we are substituting -6 for the variable. That is what we're doing when they're asking you whether it's a solution of the inequality, okay? So substituting -6 for each one of those variables. Let's go ahead and start. So -6 plus 4 less than -1, -2 less than -1. That is true. Remember, the farther to the left that you are from 0, the smaller the value. Number 9, 10 less than or equal to 3 minus -6. Be careful, people. Be careful here when you're substituting. Use a parentheses. 10 less than or equal to 3 plus 9. 10 less than or equal to 3 plus 6. My apologies there. Mistake there. That's a 9, and that is a no. 9 is not greater than or equal to 10. Number 10. So 21 divided by -6 greater than or equal to -3.5. 21 divided by -6 gives me -3.5. And this one, it's a yes. Why? You have to notice the equal sign. It's not greater, but it certainly is equal. So very important to keep track of your symbols, your inequality symbols. The next one, 4 times -6 minus 25 greater than -2. -24, -25 greater than -2. -49 greater than -2? No. -49 is much farther from 0 going towards the left. And if you think of money, which is always easier, it is better to owe $2 than it is to owe 49, right? So no. On the next one, -7 over 5 times -6 less than -8. 7 times 6, and now this is going to give me a positive number, less than -8, and the answer is no, because positive numbers are always larger than negative numbers, always. 13, 5 less than or equal to -33 divided by -6. 5 is less than or equal to positive 5.5. And that is true. While this part of the lesson is very easy, notice that I have not skipped any steps. I have shown my work. Double signs over there on number 9. Double sign over here as well, which then makes a difference when you're ready to give your answer. I've used parentheses to denote multiplication, because yes, while they're very simple, it's also very easy to make a mistake if you're not using paper, pencil, and your friendliest helper, the calculator. Okay, it says reasoning. List 4 solutions of the inequality in exercise 11. So list 4 solutions of the inequality in exercise 11. So in order for me to come up with solutions, and 4 of them, I actually need to solve. Okay, I actually need to solve this inequality. So let's start with that. 4x minus 25 is greater than -2. You solve them like you solve equations. 4x greater than 23, divide by 4, and x is greater than 5.75. What does that mean? Any number greater than 5.75. That is the actual meaning. When you read inequalities, you're always going to read them from the variable to the number. The variable could be on the left or on the right-hand side, but you're always going to read from the variable to the number. So then solution to this one, 4 solutions. The next larger number is 6, 7, 8, and 9. As simple as that. But you must solve yet first in order to find what is the solution set. Are they greater? Are they greater than or equal to? Are they less than or equal to? So you must solve first to find your solution. On page 92, now we're going to review how to graph inequalities on the number line. Okay, and you've been doing this since you were quite young, definitely since you started middle school. So the graph shows the solution set. Okay, an open circle is used when a number is not a solution. So that open circle is your departure point. Okay, and open means there's no equal sign on that inequality symbol, but that's still your departure point. The closed circle is your departure point, but now your inequality symbol will have the equal sign. So that number, your departure point, is a solution of the inequality. Okay. Now, before we continue looking at the examples done by the book, I want to write some things here where it says reflect on your method. Do you always shade the number line in the direction that the inequality symbol points? Explain your reasoning. So when you were very little, they did all that alligator mouth and you just follow, but you did not end up with variables on the right-hand side. So you really, what you must do is the following. Please write this down. No, you must, and I said it in the previous example, but now I'm going to write it. Read the inequality from the variable to the number. Always, always. This will avoid a lot of silly mistakes when graphing inequalities on the number line. For example, if I have -7 greater than x, you're going to read it as x is less than -7, or any number less than -7. So then if you know that the number has to be less than -7, it's an open circle, and you graph to the left, right? Very good. So let's take a look at the examples done for us. A and B, we can see on the screen. So y is less than or equal to -3. So with the equal sign is a closed circle, and it's clearly explained. And then if the number is less than or equal to -3, then you would have to shade to the left, including the arrow, okay? So you're going to include the arrow in your shading. It is always easier to shade with a highlighter, okay? Much easier to shade with a highlighter. Very well. Then we take a look at B. 5/2 less than x. Or the correct way of writing it, x is greater than 5/2. So no equal sign, open circle. Any number greater than 5/2, we're going to shade to the right. And we're going to include the arrow because the answers, the solutions are infinite to the left or to the right. So that's why we include the arrow. Looking at C on the same page, and the inequality was Z, the letter Z greater than 0. So 0 is not a solution, but it's going to be any number greater than 0. So again, open circle to the right, and of course, include the arrow in your shading. Again, always it's easier to shade with a highlighter. That's how I do it. I find it so much easier. And you're going to see me highlighting the same thing when we start doing the examples on page 93. Number 15, it says describe how to graph an inequality. Okay, so let's go ahead and do the description. So part A would be, hold on, let me move my, there we go. So A, so that we have it organized, we're going to draw and open. So this is summarizing how to graph. When a number is not part of the solution. Okay, we are going to draw a closed circle. Closed circle. When a number is part of the solution. And part C, we're going to draw an arrow. That's arrow. Let me fix that word. To the left or right to show that the graph continues in that direction. Well, we're not just going to draw an arrow, right? We're going to shade in that direction. Okay, now let's go ahead and graph. Now remember, when they give you the tick marks and they don't really give you the numbers, okay, just accommodate. It says any number greater than -8. So we know we have to go to the right. Okay, so accommodate your tick marks to be able to graph. So I went by fours. I started in -12. I know that it was any number greater than -8. So I know that I was going to the right. It is an open circle. And then I'm going to shade any number greater than -8 would have to be to the right. (17) 1.4 greater than or equal to G, or reading it from the variable to the number, G is less than or equal to 1.4. G is less than or equal to. So I'm going to write that so you don't forget. Okay, so G is less than or equal to, okay, 1.4. So I went ahead, and because the number was going to be less than 1.4, so I started my tick marks here, and then 0.4, 0.8, 1.2. So I started going up by 0.4s, 1.6, 2.0, and 2.4. And then 1.4 would be between 1.2 and 1.6. And then it's a closed circle because we have the equal sign. And then because that number is less than or equal to, then we will shade to the left. Okay, now next one. R is less than 1/2, any number less than 1/2. So I went ahead and I put 0 here, 1/2, 1, -1/2, and 1. You can put a 2. No, not a 2. That would be 1.5 and -1 and 1/2. And it's an open circle on 1/2. And those numbers are going to be less than, smaller than. So to the left. Now on this one, you have to simplify first. Okay, so when you simplify, V is going to be greater than or equal to, the square root of 36 is 6. So greater than or equal to is going to be graphed to the right. It's a closed circle on 6. And we're going to shade to the right. Let's go ahead and do number 20. How are the graphs of k less than 0 and k less than or equal to 0 alike? And how are they different? So alike, both have a circle at 0 and an arrow to the left, right? Because we are looking for numbers smaller than 0 on both instances. Now, different, k less than 0 is an open circle on the graph, and k less than or equal to 0 is a closed circle on the graph. On the next section, we have writing and interpreting inequalities, modeling real life. So the graph shows the height restriction in inches for the cheetah hunt right at Busch Gardens. Write and interpret an inequality that represents the height restriction. Well, we know that it's a closed circle at 48, so that's the solution. And if we're going to the right, okay, that means that those are all the possible solutions. So what does it mean? That you have a restriction and you have to be at least 48 inches to ride on the cheetah hunt, which anytime we go to any one of these amusement parks, there's always a height restriction on these rides. Okay, on the next page, in the last part of the lesson, they want me to interpret an inequality. Okay, so I'm going to give you a little hint how it's best to do this. Okay, so when they give you all these letters, it's very difficult just to look at it and say, oh, you know, this is easy to do. It's not if you don't try to give those letters a value, an actual numerical value, okay? So they're always going to give you a condition. Like if you look at it, says A represents the number of students in the school band, B represents the number of students in the school choir, where B is less than A. Interpret the inequality and tell whether it is true. Okay, so then I want you to write on the side, please, the following information. So you always remember how to do this part. So it is always helpful to substitute numbers that satisfy the conditions to gain an understanding of the inequality. Okay, so it is always helpful. Go ahead and highlight that because you're going to see the difference of how easy it becomes when you give those letters a value. So we know that B is less than A. So randomly, and don't use very large values. I'm going to let A equals 8 and B equals 4. You can use any numbers, 1, 2, okay? And then I'm going to go ahead and follow the inequality. So I have A plus B, A plus 4 divided by 2. And then it says that they're less than, right? So let's see if that's true. And then A, okay. Oops, let me see why that inequality came out like that. Let's remove the little box. Okay. Here we go. Now, so then we have 12 divided by 2 is 6, and 8 divided by 12. Okay, which then, if I just take it to decimal, I realize that 0.67 is not going to be larger than 6. And that's why you see then the answer over here. But it's much easier when you prove it, okay? When you prove it using numbers, because you can clearly see that that is true, okay? Let's go ahead and do 21 and 22. And then I have a couple of more examples on the assignment pages. Okay, so it says the graph shows the height restrictions for a ride on a water park. Write and interpret an inequality that represents the height restriction. Okay, so it's an open circle, okay? And they're using the variable h. And it's an open circle. So it's gonna be 52. So h is going to be less than 52, any number less than 52. What does it mean? That you must be less than 52 inches to go on the ride. So if you go to Disney and you go to the section with the little kids, then they won't let you ride if you're more than 52 inches, because these rides are done for little children. Okay, so I'm going to use the same numbers 8 and 4 since I used them earlier, and use the information in the example. So the information was that B was less than A. Okay, so I'm going to continue using the same information. Okay, hold on, guys. I don't know why I'm having a problem that my numbers. Try that again. Okay, so then we are going to check whether that is true or not. So 8 divided by 4 less than 4 divided by 8. That is 2 less than 1/2. And that is not true. And then on the other one, the same thing. We're going to let A equal to 8 and B equal to 4. And then let's do the substitution. So it's 4 divided by 4 plus 8, or 8 plus 4. My apologies. Something is going on that my numbers are really not coming out very well. So bear with me here. Yeah, I don't know why. But we're almost done, so I don't really want to stop the lesson. Okay, that was much better. So 4 over 12 is not greater than or equal to 1/2. So 1/3 is not, so it's not true as well. Okay, so remember, give your letters values following the condition given to you, and it will make it so much easier. Okay, so I'm going to do 3 from the assignment. Okay, so now let's go ahead and go back, and we are going to be on page 95, the first page of your homework. And let's do 19. The Sian Ren Bridge is in Guangxi Province, China. This arch is the world's longest natural arch with a length of 400 feet. Write an inequality that represents the possible length in inches of all other natural arches. Okay, so the first thing they tell us is length in inches. And they gave me a length of 400 feet. So I cannot write the inequality unless I convert my feet to inches. So 400 times 12 equals 400. Okay, so that's the first thing I have to do. And then if the arch is the world's longest, okay, if they're the longest, then that means that everybody else must be less than the 4,800 inches, right? Because they're telling you that's the longest. The next example I want to do on the assignment pages is 37 on page 97. And it says the graph shows the hourly wage requirement in dollars for employees in a state. Write and interpret an inequality that represents the state's hourly wage requirement. And it's going by 0.25s. So the inequality is going to be M greater than or equal to, I have a closed circle, 9.25. That's the mathematical interpretation, the inequality. Now let's explain it. So it says that the state requires that employees earn at least $9.25 per hour. Okay, so it's not just an answer mathematically with an inequality. It's a word problem. Remember, you have to explain. Okay, so the last one for today on page 9851. So it says a runner finishes a 200-meter dash in 35 seconds. Let R represent any speed in meters per second faster than the runner's speed. So first thing I'm going to do before I do anything with this graph is find the runner speed. Okay, so, and we say that it's going to faster than the runner speed, so it's going to be faster. Okay, so let's hope this works well because my pen is acting a little funny. Okay, and then it's faster than the runner's speed. So it does not include the speed of the runner. It's just faster than the runner's speed, but it won't include the speed of the runner, okay? So then, let's see. So faster, 5.71 would be somewhere around here. I hope that this kind of falls correctly. Okay, and then faster would have to go to the right and the arrow, of course. Now, let's take a look at the other questions. Every point on the graph in part A represents a speed faster than the runner's speed. Explain why every point may not represent the speed runner. Because the graph includes, right? Because we were told that speeds that are faster. It didn't say faster or equal to. Can run, right? So that's why it's greater than, faster than the runner can run, faster. Okay, show how you can use a second inequality to alter the graph in part A so that every point represents a possible speed of a runner. Well, we could have said, okay, so R greater than R 5, oops, hold on. Are 5.71, right? And also graph, let's say less than 10, right? Because then it would include between 571 and between 10. Okay, so once you are done with listening to the notes and taking complete notes, then you have instructions on how and what to do for the assignment. We're going to try to do the assignment using the online platform, okay? I have given you specific instructions how to find it. I have also told you the problems you're going to be working on. Now, when you go to the online platform, they're being listed as 1, 2, 3, you know, so on and so forth. But I have told you that if you follow your workbook, which I want you to use to do all your work, okay, your workbook, then you follow the problems as I listed them for the workbook pages. You must show your work in your workbook. You're going to have the ability to check your answers. And I want you to write in your percentage in red, and you bring the pages to the classroom, okay? And then we will go over any questions, okay? Any questions dealing with concerns, okay? So since you are already checking it with the online system, only if you were not able to figure it out and you still have more questions about it, then we will go over those questions, okay? Have a wonderful rest of your day. Bye, everybody.